Thanks to ChatGPT, Google Bard and Bing, artificial intelligence has been the talk of the town as of recent. AI has come a long way since its inception in the gaming industry, and today we'll delve deeper into its history, its various applications in games, and how it's revolutionizing the gaming experience. Today, we explore the seemingly unstoppable journey of AI in video games. My name is Chris, and this is Gamers Delight. Let's begin with a brief introduction to AI. Artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think, learn, and make decisions just like humans. Even though we've only recently started to talk about AI in a larger context, it's been a part of everyday life for the last couple of years. Be it in the form of content suggestion, face recognition, or voice assistance, it's almost impossible to imagine modern life without AI. In the context of video games, AI is the technology that drives non-player characters, in-game creatures, and other elements that interact with the player to create a more immersive and engaging gaming experience. The history of AI in video games can be traced back all the way to the 1950s, when computer scientists started experimenting with simple games like tic-tac-toe and chess. These early games utilized basic search algorithms to simulate intelligence, such as the Minimax algorithm, which calculates the optimal move based on the assumption that the opponent will also play optimally. These early AI systems laid the groundwork for more sophisticated AI in video games. One of the first significant milestones in AI for video games was the development of the game Space War in 1962. This game featured a simple AI-controlled ship that would move around the screen and shoot at the player. Space War was one of the first video games to demonstrate a basic form of AI interaction, paving the way for more complex AI systems in the future. In the 1980s, games like Pac-Man and Donkey Kong demonstrated a more advanced level of AI. The ghosts in Pac-Man, for example, exhibited unique behaviors based on their very own personalities. Blinky aggressively pursued the player, Pinky tried to anticipate the player's movement, Inky combined aspects of both, and Clyde moved randomly. This simple AI behavior system, which relied on a combination of pre-scripted and dynamic movement patterns, made the gameplay more engaging and challenging. The game Donkey Kong featured varying enemy behaviors and patterns, such as the barrel-throwing patterns of Donkey Kong himself, just like the fireballs and rolling barrels that could adapt their movement patterns based on the player's position. These early AI innovations added both depth and variety to the gameplay experience. The 1990s saw a considerable leap in AI technology with games like Sid Meier's Civilization and the Elder Scrolls series. Civilization showcased more complex decision-making processes for AI-controlled civilizations, including diplomacy, resource management, and military tactics. The AI opponents in Civilization were designed to adapt their strategies based on the player's actions and the game's world state, resulting in a more dynamic and engaging gameplay experience. The Elder Scrolls series introduced AI-driven NPCs with basic behaviors and schedules. This was a significant step towards creating more immersive game worlds filled with believable characters. The series also featured AI-controlled enemies with different combat tactics and abilities, adding variety and challenge to the gameplay experience. The late 1990s saw significant AI breakthroughs in gaming, such as the revolutionary Half-Life. Half-Life featured AI-controlled enemies that could work together, flank players, and dynamically react to the environment. The introduction of the Unreal Engine in 1998 allowed developers to design more lifelike AI characters with advanced movement, animations, and pathfinding capabilities. The Unreal Engine's AI tools, such as its navigation mesh system, made it easier for developers to create realistic AI behavior and helped to further revolutionize the gaming industry. In the early 2000s, games like Black and White demonstrated the potential of adaptive AI. Black and White, a god simulation game, allowed players to teach their AI-controlled creature to perform tasks by rewarding or punishing its actions. This introduced a new level of depth in AI behavior, as the creature would learn and adapt based on the player's input. This AI system, called neural networks, allowed the creatures to make decisions based on a series of weighed inputs, simulating a learning process. The mid-2000s to 2010s saw the rise of open-world games, which demanded even more complex AI systems to bring their vast, dynamic worlds to life. Games like GTA 4, Skyrim, and The Witcher 3 Wild Hunt featured AI-driven NPCs with their own schedules, behaviors, and interactions, making these worlds feel more alive and immersive than ever before. A notable example of AI development in this period is the Radiant AI system used in Bethesda's Elder Scrolls series. This system allowed NPCs to make decisions based on their needs, relationships, environment, and thus creating a more believable game world. For example, NPCs in Skyrim would go about their daily routines, engage in conversations with other NPCs, and even react to events happening around them, such as dragons attacking the town. The late 2010s saw the application of deep learning and procedural generation techniques in AI for video games. Deep learning, a subset of machine learning, enabled AI to learn from large amounts of data and improve its performance over time. This led to the development of AI that could generate more realistic and varied content, such as terrain, animations, and even entire game worlds. A notable example of procedural generation in gaming is No Man's Sky, a space exploration game that uses AI algorithms to generate an almost infinite universe filled with unique planets, creatures, and environments. The game uses various algorithms, such as Perlin noise and L systems, to create procedurally generated terrain, flora, and fauna, offering an ever-expanding universe for players to explore. Today, AI in video games has reached new heights, allowing for even more dynamic and emergent gameplay experiences. Games like Red Dead Redemption 2 and Assassin's Creed Valhalla showcase advanced AI systems that control wildlife, weather, and NPC behavior, creating an ever-changing world for players to explore. In Red Dead Redemption 2, for example, the AI system dynamically generates random events and encounters, making each player's experience unique. Recent advancements in AI technology have also led to the development of AI-driven game characters that can learn from player actions and respond accordingly, creating a more immersive and engaging experience. AI has also played a significant role in the rise of competitive gaming and esports. AI-driven tools like Dota 2's OpenAI 5 and Google's DeepMind AlphaStar have demonstrated the potential of AI to compete against top human players in complex strategy games. These AI systems learn and improve by playing millions of matches against themselves, refining their strategies and decision-making processes over time. The development of AI in esports has not only provided new challenges for competitive gamers, but also helped advance AI research by exposing the technology to complex, real-world scenarios. For example, OpenAI 5's success in Dota 2 has led to further research into reinforcement learning and transfer learning, which can both be applied to various fields outside of gaming, such as robotics and autonomous vehicles. Looking toward the future of AI in video games, we can expect even more sophisticated AI systems that will continue to push the boundaries of what's possible in gaming. We may see AI-driven characters with fully autonomous decision-making capabilities, creating more unpredictable and engaging gameplay experiences. One example of this is the AI system called Seed, developed by Electronic Arts, which aims to create more lifelike characters that can learn and adapt their behaviors over time. Additionally, we can anticipate further advancements in AI-generated content, leading to even larger, more diverse and more immersive game worlds. Another promising aspect of AI in video games is its potential to make games more accessible to players with disabilities. AI-driven systems can adapt gameplay experiences to cater to the specific needs of individual players, making games more inclusive and enjoyable for everyone. For example, AI could be used to adjust the difficulty level, provide alternative control schemes, or offer dynamic audio cues for visually impaired players. However, the development and implementation of AI in video games also raises some ethical considerations. As AI-driven characters become more realistic and lifelike, questions arise about the potential impact of violence and other mature content in games. This poses a challenge for game developers and regulatory bodies to balance the benefits of advanced AI with the need for responsible content creation and consumption. Additionally, as AI continues to play a significant role in the gaming industry, the potential misuse of personal data collected by AI-driven systems becomes an important concern. Ensuring the ethical use of AI in gaming requires developers to prioritize data privacy and security, as well as to adhere to established guidelines and regulations. From its humble beginnings in simple games like tic-tac-toe to the advanced AI-driven characters and worlds we see in today's games, AI surely has come a long way and will continue to shape the future of gaming. I hope you enjoyed this journey through the history and evolution of AI in video games, and you're as excited as I am to see what comes next. Thanks for tuning in, consider subscribing and joining the discussion in the comments. My name is Chris, and this is Gamers Delight.